Good morning, everybody. Let's give this polynomial right here a name. Let's call it P of X just for future reference. Now, y'all, what we're given is a polynomial that is not monic. That is, it has a coefficient other than 1 in front of the leading term. It's also specified it has 3 roots. It's not stated whether they're distinct or not, or whether they're real or complex or anything. It really doesn't make too much difference here. Okay. Now notice the polynomial that we're studying is equivalent to this monic polynomial. And how did we get this monic polynomial? Well, we divided everything inside by 20. Notice that 18 over 20 reduces to 9 over 10. Okay, so any solution to the polynomial of interest is a solution to this easier to analyze polynomial, even though it does have rational coefficients at this point. Notice we divided 0 by 20. That's our free lunch. So since we have A, B, and C as roots, not necessarily distinct, it's the way the processing goes, it's not really important. And so our P of X, which is equivalent to our polynomial of interest, can be written in this form by just the factor theorem. If you have a 0, you have a factor. All right. Now notice how some nice things accumulate, like right in front of here, you have the negative sum of the roots, right? So we know that minus 20, minus 19 over 20, by just comparing coefficients, basically, or equating coefficients, is equal to A plus B plus C, which is the sum of the roots. And thank you, Dustin. You're a good man. The world needs more people like you. Okay. Now, right here, folks, you have also ABC. And again, this is just by equating coefficients, equals to minus 17 over 20. Okay. And you'll see there's another thing we can equate here where for the AB plus AC plus BC, that presents right here as the coefficient of X. Okay, but let's move along and see how we can solve this monster of a problem by just doing some fairly simple algebra. Now the expression that we're trying to find the value of admits this fairly simple factorization. And notice we already have minus 17 over 20 in front of a squared plus b squared plus c squared. You see the minus 17 over 20 we got right here belongs right there. So you see we're on our way. We just have to know what a squared plus b squared plus c squared is. All right. Well, again, this multiplication down here is not too hard to see. When you expand this out, you get double all these things here. Okay, the pairwise product of the roots, right? Okay. And so we can see quickly that a squared plus b squared plus c squared is equal to minus 19. You see, again, we determined minus 19 over 20 is the sum of the roots, which belongs right there. Now this AB plus AC plus BC appears, you see right here, when you expand all this stuff out, you get AB plus AC plus BC presenting as the coefficient of X. So that's why we can put the 9/10 right there. You see how nice this is? Now, y'all, one thing to notice about this computation, I'm not going to show you each of the arithmetic steps, but you know it has to be something over 20 cubed. Right? Over 20 cubed. That's because you have a 20 here, then you have a 20 squared here. Okay? So that'll be your common denominator, so to speak. And after you do all the arithmetic, you get 6103. You end up, and again, I'm not gonna bother with the arithmetic. It's something we all can do if we need to. But in the name of brevity, I'll just write down this. It's 6103, which ends up being the same thing as 61 over 3, and 20 cubed is what, 8,000? And again, folks, I'm leaving out some steps that are important for people who are trying to learn arithmetic. But I'm presuming most of you guys are adept at arithmetic, and I don't want to spend too much time on this aspect of it right here. So this is what I got. Let me know if you got the same thing or if I made a mistake somewhere on the arithmetic. But I do know that the overall principle that I adhered to was correct. It's called Vieta's formulas, by the way, Vieta's formulas. But you don't have to memorize Vieta's if you just know how to expand. This leads to a result called Vieta, and this is the third degree result for Vieta. And it's nothing too sophisticated. It's an Italian name, I think. And it gets harder if you have a higher degree polynomial. You know, to expand out even a fourth degree polynomial is kind of a pain. This is tedious. I didn't show the work on it, but this is what you end up with. But essentially, Vieta's ends up equating coefficients that alternate, kind of, okay, just based on the way this object expands out, okay. So anyway, the final answer I got is 6103. Okay, that's what I got, 6103 over 8,000. Pretty sure it's correct, but you may want to double check in the event I made an arithmetic mistake. Okay, thank you for viewing.